Welcome to lesson 5-1. In this lesson, we're going to be looking at some of our quadrilateral shapes. So let's start with a review of some of our geometric curves. So here we have a list of terms and list of definitions. So take a moment to see what you can match, and then unpause the video to see what you got. So we could have matches here. Parallel. Next, quarter to quarter through the middle. So that is that angle. Next, we have two angles that cross in an X. So that is a vertical angle. Directly across from each other. They are opposite. Sum of two angles is 180 degrees. That's supplementary. Same size and shape is congruent. Cuts in half with two equal parts. Bisect. And this was the last part here. Angles next to each other. Consecutive. A little crazy in matching there, but you can see that that's just some of the terminology right here from this video. So we want to look at its properties and their converse to prove if quadrilateral is a parallelogram and vice versa. When completing the informal proof, you must start with the known evidence. So we're going to be working with these using our conditional statements. Remember, that's if you state your evidence and then your outcome. Okay? So here for parallelogram, these are a lot of features for a parallelogram, and then we're going to see that there's a subset of those features as well. So if it is a parallelogram, both pairs of opposite sides are parallel. If it's a parallelogram, then the opposite angles are congruent. Okay? So that tells us here when we talk about opposite angles, we can here and here. If a parallelogram, opposite sides are congruent. This. And then if parallelogram diagonals bisect each other, so we do this here. Bisect small. If parallelogram consecutive angles are supplementary, so these two angles together would be 180 degrees. Right? And then another pair of consecutive angles would be here, 180 degrees. And then here's the last kind of sums up a little bit, but if it's a parallelogram, both pairs of opposite sides are parallel and congruent. So that kind of puts two of those pieces together. Other quadrilaterals that can be classified as parallelograms. A rectangle is the first one. Notice here it's a parallelogram. We have some of the same features. Right? We have opposite sides are congruent. We have opposite sides are parallel to each other. Diagonals. Let's see the dotted lines are bisected. So it's a lot of the same features in a rectangle as in a parallelogram. But also something that's different is that if it's a rectangle, then it has four right angles. And to call them our evidence, if it's a right angle, this means adjacent slope. Opposite and reciprocal. See that in our upcoming videos. Okay. And then if it's a rectangle, the diagonals are congruent. So that means this line here is going to be the same as this line here. You can use distance formula to get that. So scrolling down, a right angle forms when the slope of two lines are opposite and reciprocal. So just to restate that, something that you can look at in your evidence. Another parallelogram is the rhombus. Some things that are different about the rhombus. The rhombus has all the same characteristics as the parallelogram from the first slide, but it also has four congruent sides. If the rhombus, then its diagonals are perpendicular. So when I draw these lines here, they're perpendicular, they have opposite reciprocal slopes. That means I get 90-degree angles here. So that's 90 degrees. Opposite reciprocal. If it's a rhombus, the diagonals bisect opposite angles. So it's hard for us to tell these proofs. You have to put a piece of information and use too much. We can see that it does work. And because of the shape of the rhombus, those consecutive angles still add up to 180 degrees, but they are not congruent. Well, the square is kind of nice because if a quadrilateral is a rectangle and a rhombus, well, then it's also a square. So if I look at a square here, let me just bring this up real quick. has all of those features, right? It has opposite sides are congruent, opposite sides are parallel, it has the 90-degree angles, it has the diagonals that bisect the angle, it also forms 90-degree angles at the intersection. So there's a lot of features there when you get to that. So what you could look at to do to organize this is set it up in a Venn diagram. See, the parallelogram is a big category because it has components, and then within that, the rhombus and rectangle, when they share those characteristics, then you have the square. Other quadrilaterals that are not parallelograms, and the reason they're not parallelograms is they don't have 4 congruent sides. First is a trapezoid, and this could be a regular trapezoid, sometimes a right trapezoid, depending. But what you have is one pair of parallel sides and 2 non-parallel. So if I sketch this here, base 1 and base 2 are parallel to each other, but the 2 side lengths aren't. And as well, the 2 side lengths are different lengths, making a trapezoid. If a trapezoid has only one pair of opposite sides, the bases are parallel. Another piece of information that we could look at here is that the diagonals are not congruent. You can see a regular trapezoid. And isosceles trapezoids have one pair of parallel sides and congruent non-parallel legs. So here, again, we get some of the same features, right? Lines, but this time my 2 side lengths here and here are congruent to each other, which means my diagonals are congruent, which is a distinguishing feature between these two. So it's hard sometimes to get that information. So for isosceles trapezoid, legs are congruent, and isosceles trapezoid base angles are congruent. So the base angles will be here at the bottom of one of the bases, or the other base, right? Base 1 or base 2. And lastly, for the isosceles trapezoid, diagonals are congruent, stated that already. The last shape that we have is a kite. The kite kind of works because there are no parallel sides, so that's the first piece of evidence that you have. So if you have a kite, then 2 pairs of consecutive sides are congruent, but opposite sides are not. So here I have a consecutive side, and it's congruent, but the opposite sides are not. Those 2 consecutive sides are congruent. If a kite, only one pair of opposite angles are congruent. So here and here, you have a measure here and here, but then they all have 360. And if it is a kite, then the diagonals are perpendicular, they form 90 degrees. Again, hope you found this helpful. I'll see you next time.